I'm guessing if you're watching this video, you want to learn a little more about these rocks. You've got questions like, where do rocks come from? What do rocks want from me? Well, let's just start with a wacky song.
Alright, let's go. Sedimentary rock, igneous rock, metamorphic rock. This ain't a rock song. Sedimentary rock, igneous rock, metamorphic rock. This ain't a rock song. Sedimentary, it's very ordinary. Most common class of rock. Think limestone building blocks, sandstone building clocks, locked in time, fossil parking lot. Fossil parking lot. Sedimentary rock, igneous rock, metamorphic rock. This ain't a rock song. Sedimentary rock, igneous rock, metamorphic rock. This ain't a rock song. Okay, the next rock I'll talk about is the igneous rock. Just picture a volcano with a red goo spewing out. Volcanoes give me what I need to exfoliate my face. Sedimentary rock, igneous rock, metamorphic rock. This ain't a rock song. Yo, let's talk about that metamorphic rock. Metamorphic rock. See, first it has to be a sedimentary rock or an igneous rock to even become a metamorphic rock. And it only becomes a metamorphic rock if it undergoes enough heat and pressure. It's like you're re-cooking an existing rock. Like when you left the pizza in the oven too long. The best place in the Grand Canyon to find metamorphic rock is at the bottom.
This ain't a rock song. Three types of rock would be like heavy metal, classic rock, indie rock. This is a geology song.
Let's go deep down in the canyon. Rock, slide, little rock, slide, conglomerate. Rock, slide, little rock, slide, conglomerate. A conglomerate is a type of sedimentary rock. To truly understand why we put rocks in these three classes, we need to examine how rocks are formed.
In the bottom of this image, we can see a sedimentary rock called limestone. This limestone makes up the uppermost layer of the Grand Canyon. We find limestone on the north side and on the south side of the canyon, so we're pretty certain that there was once no canyon, and all of these rock layers would have just continued all the way across. Which actually means we believe the limestone layer of rock sitting at the top of the Grand Canyon was formed long before the canyon and long before the Colorado River ran from the Rockies to the Gulf of California. So, how is limestone formed? When we look closely at limestone, we will find sea fossils like this. And this is because limestone is rock created from the sediments found at the bottom of the ocean. Does this mean ocean levels used to be 7,000 feet higher than they are now? Not exactly. See, after rocks form, they can be pushed all around, all over the world. But that's a whole other story. I want to focus on how these three classes of rock are formed, because that's the reason that we put them into three different classes, is because of how they're formed. Starting with sedimentary rocks. Sedimentary rock is made up of sediments, and Sediments are basically the matter. Imagine, if you filled up a glass of water, sediments are the matter that would settle to the bottom of a glass. So if you dipped a glass into some swampy water, the sediments would be what ends up settling at the bottom. And these sediments are commonly sand, dirt, pebbles, crushed seashells, and so on. Sedimentary rock is made from sediments. Now, if you've ever baked bread or cookies or cake, you've seen a great example of something similar to how sedimentary rock is formed. Imagine if flour and sugar are the sediments. When we mix the flour and sugar with water, they begin to get stuck together. They get all gooey and sticky. And if we then heat our dough in the oven, this excessive heat for a long amount of time will basically dehydrate the dough. Once we pull our biscuits out of the oven, they are now solid. A very similar process is happening all the time with sediments. Yet, it takes a much longer time than baking a loaf of bread for nature to create a rock. Imagine if you had a swamp, and thousands of years from now, that swamp is going to dry up due to changing climate. There would be mud left behind as that swamp dries up. And if this mud baked in the sun and were then pressurized, because it's not just heat that turns sediments into rock, it's often pressure as well. With pressure, you can imagine if someone kept putting on t-shirt after t-shirt after t-shirt, that person would start to get very hot. Their body would be getting squeezed tight under the pressure of all those t-shirts. And this is basically what would happen in nature if the swamp dried up, the sun baked the mud, but that mud would also get buried under more and more sediments. Mud from swamps typically turns into a rock called shale. If coastal beaches dry up or sand dunes get buried and pressurized, that will become sandstone. If an ocean dries up, we can imagine ocean levels dropping during our most recent ice age as more and more water was becoming sucked up and frozen at the poles of the earth. The dropping sea levels would expose sea floors, which would dry up and would be heated by sunlight and buried under layers of sediment, eventually turning that sea floor into a rock called limestone. Now, this is starting to get a little messy. Yet, I hope you can understand what I'm trying to show. I'm trying to show that in the Grand Canyon, we see layers of limestone, multiple layers of sandstone, shale, meaning the newest layers to form are at the top. And as we go back further in time, think of it like a laundry basket. Things are laid in the laundry basket. Your latest clothing is on top of that laundry basket. If we go further back in time, we can see that this area known as the Grand Canyon, it was ocean, it was sand dunes, it was ocean again, it was, swamp, just all these different things have happened throughout Earth history. And that's what the study of rocks, that's what geology is all about. You're a detective. You're looking for clues. So what you really need to get out of this is that the source of the sediments that are going to create the sedimentary rock, that source is going to determine the type of rock. Limestone, sandstone, shale. And because the limestone has sea fossils in it, that's how we know it's limestone, but that also tells us that this was an ocean. So just remember, sedimentary rock is made from sediments. Heat and pressure turn sediments into rock, and the source of those sediments determines the type of sedimentary rock. Before I completely overload you with information, let's just take a deep breath, relax, imagine you are a child and you're playing in the dirt. Where do sediments even come from to begin with? Well, sediments are basically debris. Sediments are dirt. Think of leaves falling, pine needles falling, birds pooping, twigs breaking, and then worms eating this stuff and pooping it out. That's where sediments come from. Or in the oceans, at the bottom of the sea, sediments come from broken shells, debris of coral, crab shells, and fish poop. Also think that when snow melts off the top of the Grand Canyon, that water is going to fall to the bottom, to the Colorado River, and all along the way it's going to push little bits of sediment. So broken pieces of existing rocks are going to be pushed down to the Colorado River, and that river is going to take those tiny little sediments and dump them out into the oceans, falling to the ocean floor. So water and rocks are constantly cycling, recycling, being created and destroyed. First, you have to get the sediments, then you get the sedimentary rocks. In the beginning of the video, I mentioned limestone being a building block. Limestone rocks are often used in all sorts of construction. Limestone is very common because much of the earth was once covered by oceans. We have various great flood stories from many cultures, and limestone is great evidence that the earth was once mostly covered by ocean. Northern Africa was under the ocean. We know this not only because of the sand dunes of the Sahara Desert, but also because of all the limestone and even salt deposits found there. The pyramids of Egypt are made from giant limestone blocks. And if you were to examine the blocks of the pyramids closely, you would find sea fossils in them. While I mentioned limestone as a building block, I mentioned sandstone being used to build clocks. The giant slabs we find at Stonehenge are made of sandstone. And although mysterious, many believe Stonehenge's original purpose was to tell time by having these giant rocks lined up with celestial movements like that of the sun, the moon, the stars. And when I talk about sedimentary rocks used for buildings, it's also worth mentioning ceramics and concrete. Concrete is pretty much a man-made rock, which we use for walkways and foundations. It's solid, it's strong. If you were to take limestone and crush it up into a powder and mix that with sand and gravel and water, you could make concrete. Ancient Romans used a mix of volcanic ash, lime, and seawater. If you've made a clay pot or mug, you've also experienced a similar concept as to how Mother Nature makes sedimentary rocks. Clay is just finely filtered mud. And when we shape clay, as it's drying out, we can mold something like a coffee mug or pot. Take that clay pot and throw it into a kiln and heat it at very hot temperatures of 1,000 to 2,000 degrees Fahrenheit. This will dehydrate the clay and give us a ceramic. Porcelain is a very finely filtered clay. You can think of that as very fine. If you know sandpaper, you have coarse sandpaper to fine sandpaper. In sedimentary rocks, we have a very coarse rock, a conglomerate, and then we have finer rocks like sandstone and limestone. So in the world of ceramics, porcelain is very, very finely filtered clay. And if you're fortunate enough to have a toilet in your home, you've probably developed a very intimate relationship with porcelain. So there you have it. Sediments becoming solidified into rocks. Sedimentary rock, made from sediments. And why do I call sedimentary rock a fossil parking lot? Well, fossils almost only form in sedimentary rocks. Sedimentary rocks come from the living part of the earth, the biosphere. Coal is a sedimentary rock, and coal is basically just very highly compressed plants. So if a fern or leaf is hit with a mudslide, and that mud is covered by more and more sediments, thousands of years later, you will be able to find a fern fossil in that mud that had turned to rock. The same thing happened from ancient creatures walking on wet sand. That wet sand could have dried out and then solidified into sandstone. These are ancient footprints found in the Grand Canyon. They're from some sort of a mammal-like reptile which predates dinosaurs. The 5-digit footprints are now solidified into a block of sandstone.
I have something to present to you guys, is what they say are some of the oldest fossils in the Grand Canyon. Now, not the oldest fossils. I'm drunk, but these are footprints. These are footprints in a rock. So this rock broke off of the cliff just behind my back here. And that big rock broke down and fell, and they noticed these footprints in the rock. And so these are from an ancient creature, basically predating dinosaurs, because every layer of the Grand Canyon predates dinosaurs.
This one fell, and when these rock slides happen, you get this hidden history revealed.
Understand that there is always magma under the surface of the Earth. Under the Earth's tectonic plates, we've got this magma. When the magma erupts through a volcano, we call it lava. And when lava cools really quick, we get igneous rocks like basalt or obsidian. Obsidian is very much like glass. So if I'm going to talk about the formation of igneous rocks, it's worth talking about the making of glass. When we make glass, we take some of the same ingredients from concrete, things like crushed limestone and sand, and go extra heavy on the sand. Instead of just mixing them with water and letting these ingredients set, we heat them up. That's how glass is made. So obsidian, or as some like to call it, dragon glass, is basically Mother Nature's glass. Now, if the red goo, or magma, pushes towards the Earth's surface, but doesn't quite make it out by erupting from a volcano, well, this magma is still further from the fiery core of the Earth. So even though it didn't make it to the Earth's surface to turn into lava, this magma will still cool off and solidify slowly, thus creating igneous rocks like granite.
This is granite. Now, this is sitting within a metamorphic rock called schist. It's what we call a granite intrusion, the pink. This is magma that pushed up and it went into the cracks of an existing rock. All of this happened below the Earth's surface.
Think of magma, or this red goo, like the melting down of old rocks. Almost like if you were to melt down gold or silver and they're glowing red. When volcanoes allow for magma to erupt into lava, the rocks that are then formed from this cooling lava are basically fresh new rocks being welcomed back into this world. The San Francisco peaks just south of the Grand Canyon are the remains of an ancient volcano.
And now we're at the big crack.
And what is this feature out here? So if I look this way with the camera, we can still hear you with the mic.
Okay, I can try and be a finger here.
So check this out.
This one there.
Yeah.
Humphreys. So we cycled up to 9,000 foot, just on the right-hand side of the snowy peak. They had a beautiful single-track descent. Again, another beautiful single-track descent.
ACTV.
Yes,
When were you
Arizona
guys there?
Trail.
How long ago were you there?
2 days. 2
I think
days?
we
3
did,
days?
160 kilometers in 2 days.
About that, yeah.
About that.
Lots of climbing. With lots of climbing. Yeah, it's beautiful.
Yeah,
Absolutely
it's
beautiful.
The Hawaiian Islands were formed from volcanoes erupting from the ocean floor and pushing all the way up to the ocean's surface to create habitable islands. Point Dume in Los Angeles County is also a great place to see exposed igneous rock. The rocks making up the point of Point Dume are even more remains of ancient volcanic eruptions. So, sedimentary rocks are made from sediments. Igneous rocks are made from freshly cooled magma or lava. And if igneous rocks are some of the freshest, newest rocks, then metamorphic rocks could be considered the oldest. Igneous rock can come from a volcano. Sedimentaries glued together by worm food. Metamorphic. This schist is becoming nice. Then it all turns back into red goo. Rocks are all about eternity. Allow me to clarify the rock cycle. Igneous rocks are known as the youngest rocks because they are formed from magma. But magma is molten rock, right? So igneous rocks are technically made from old molten rocks. That red goo in a volcano is not only the end of a rock's life, it is also the beginning. Igneous rock can come from a volcano. Sedimentaries glued together by worm food. Metamorphic. This schist is becoming nice. Then it all turns back into red goo. That red goo is special. And remember, it's called magma until it reaches the surface of the earth, and then it's called lava. But I just like saying red goo. That red goo in a volcano is sort of representing death and rebirth. I mentioned this earlier. It's a lot like if you melt down gold. Imagine if you're going to melt down a bunch of old gold jewelry to make a shiny new gold ring. It's endless. A circle. A cycle. Eternal. So, once magma or lava has hardened into new rock, pieces of those igneous rocks can chip off and become sand. And that sand, also known as sediment, can go into making a sedimentary rock. An igneous rock could also get buried very deep, and through the process of metamorphism, become a metamorphic rock. Sedimentary rocks, on the other hand, are not young or old. Remember, sedimentary rocks have to come from the biosphere. They have bits of organic matter in them, and they have to be sedimentary before they can become metamorphic. So sedimentary rocks are kind of in the middle. They can't be younger than the youngest igneous rocks because sedimentary rocks take thousands to millions of years to form. In fact, igneous rocks are really the only rocks we can witness forming in a human lifespan. Now, metamorphic rocks could form quickly, yet it usually happens deep down underground. And I say metamorphic rocks are the oldest because metamorphic rocks had to have been sedimentary rocks or igneous rocks first before becoming a metamorphic rock. So they're old, they're special. The older the rock, the more information it can give us. And if metamorphic rocks get buried too deep in the earth and they come in contact with magma, they will melt back down into red goo, like a computer crashing and losing all of its data. So anything can become magma and thus start the cycle all over again. The rock cycle.
Metamorphic. Metamorphism.
How exactly do these
Metamorphic.
rocks undergo a
Metamorphism.
Well, let's start with one example. Here's limestone. Now, limestone is buried deep by the deposition of new sediments. So imagine this piece of limestone is buried deep underground, and what else is underground?
Liquid hot magma.
If the limestone heats up from coming in contact with magma, it will turn into marble. But if it heats up too much, it will turn into red goo. So this type of
Metamorphism.
is called contact metamorphism. The existing rock changed because it came in contact with magma. And yes, many statues are made out of a metamorphic rock called marble, like David, the Taj Mahal, the Washington Monument, and Abraham Lincoln sitting inside the Lincoln Memorial.
A great American in whose symbolic shadow we stand today.
It's almost as if the architect was trying to tell us the story that Abraham Lincoln went through. He went through his own sort of
Metamorphosis.
Now, another way that a
Metamorphic.
rock can undergo a
Metamorphism.
is regional.
Metamorphism.
This happens when tectonic plates are crashing into each other and the pressure is so extreme the existing rocks undergo
Metamorphism.
like schist becoming nice. Really,
Metamorphic.
rocks are tortured rocks. They've sort of been beat up and recooked. Kind of like when you kept the pizza in the oven too long. The best place to see metamorphic rocks is at the bottom of the Grand Canyon. Some of these
Metamorphic.
rocks have been brought up and are on display at the top of the canyon, like Vishnu Schist and Elves Chasm Gneiss. These
Metamorphic.
rocks are believed to be billions of years old. And because these old rocks get so far buried underground, it is only in places like the Grand Canyon that we get to see them re-exposed to the biosphere. Grand Canyon is a special place because in one eyesight, you can see all three classes of rock. Remember, the next time you find a rock, that rock probably has many stories it would love to share with you, if only you know how to interpret its language.
Grand Canyon TV